Alright, yes, welcome to the session, and I hope all of you guys are doing good. So let's get started with today's discussion. The learner with the name A, write your name properly, else I will remove you from the class. Learner with a name A, write your name properly, else I will remove you from the class. All right. So let's start with the discussion. So today we are going to talk about correlation, right? Now, what is a correlation? Yesterday we saw a bit of a understanding, but today we'll be talking about a bit of mathematics as well. So for example, let's say I want to predict, or let's say I want to find a relationship. Let's not get into the prediction part, but let's say I have the experience, or let me do something else. Let's say area of my house, and I want to predict my house price. Right, house price. So here you can see a pattern that when my area is increasing, my house price is increasing, right? So this type of relationship, I can say there is a linearity, or I can say there is a correlation. That means when one particular feature is increasing, my other feature is increasing as well, right? So there is a linearity. Same way, my house price and distance from the city. When the distance is increasing, my house price is decreasing, right? So here you can see that it's a negative relationship. Here it's a positive relationship, right? When one is increasing, other is increasing as well. Here, when one is increasing, other is decreasing, right? So this is a positive type of relation. It's a negative type of relation. Why we are saying positive and why we are saying negative, that is what we have to discuss, right? But there is a correlation. That means when one is changing, other is also changing. But when I see this type of data, for example, kids' age and house price. Here is the kids' age and here is the house price. Now here I don't see any relationship. It's very much scattered, right? My data is very much scattered. So here there is no relationship. So there is no relation, no correlation. So that is what we are going to discuss. Imagine two things. When you eat more junk food, your weight increases, right? So basically, when you are having more food, more the weight will increase. When you study more, your marks will increase, right? So there is a relationship between the study hours and your marks. That's called correlation, a measure of how two variables move together, right? If both go up together, it's a positive correlation. That means as my area of the house is increasing, my house price is increasing as well. That is the positive correlation. If one goes up and other goes down, that is my negative correlation. That means, let's say when the distance from the city is increasing, my house price is decreasing. It's a negative relationship. And when there is no effect on each other, in that case, that is known as no correlation. There is no correlation between this thing, right? Two features. The example which we have seen, that is nothing but your, what do you say, kid's age and house price, right? So here there is no relationship between these two features. So in that case, there is no correlation. Now, how will I measure this? That we got it. Okay, that's fine. That there is a correlation, and when there is one is increasing, other is increasing, it's a positive. One is decreasing, other is decreasing, other is increasing, it's a negative, like that. So we got that understanding by seeing these pictures as well. We got the understanding, but how can we calculate that? What all measures are available, basically, right? So why correlation is important? First of all, suppose I want to do some predictions or I want to find some relationships, right? In that case, it is very important for us to find out, to understand relationship between two data columns, or data columns basically, two or more, that's fine, to check which features affect the target, right? Suppose I am creating a machine learning model. Suppose, let's say I want to predict the house price based on the area of the house. So as the area is increasing, house price is increasing. So I can very well say that area is an important factor to decide the house price, right? So that is what it is mentioning, to check which feature affect the target. What is my target? House price. Which feature I am talking about? Area. Is area affecting my target? Yes. Is area affecting my house price? Yes. When area is increasing, house price is also increasing. So that is an important feature for me, right? To detect redundant data, two features are highly similar. For example, let's say, suppose I want to predict my salary based on the experience. When my experience is increasing, my salary is increasing. Same way, I want to predict my salary based on the age as well. When my age is increasing, my salary is increasing as well. But interestingly, when my experience is increasing, my age is also increasing, right? So that is what this line is saying. To detect redundant data, two features that are highly similar. Here, age and experience are highly similar, right? Because age is derived, or I can say experience is derived from age only. When your age is increasing, experience is increasing. So basically, they are similar features. So that is also helping me understand that whether the features are similar or not. And if it is similar, are they correlated? If they are correlated, that means yes, maybe I will be okay to go with only one feature, right? The idea is that suppose I want to predict the salary, I'm okay to go with experience, right? Why will I go with age in that case? Because age and experience are all like having a relationship, right? So age and experience are of same type. So if I want to find out the salary, only experience is really important. Age I can ignore. Why we ignore and all those things, we'll discuss a bit of detail in the machine learning in the future sessions, right? But basically the idea which I wanted to tell you, why we need correlation, to understand the relationship between the data, to understand which features are important to predict something, to understand whether there are some features which are of same type with good correlation. I can ignore some of the features from them. And lastly, to make a better business decision. So the real-time example is, when you study more, you get a high score on test. It's a positive correlation, as we discussed earlier as well. When you exercise more, you lose the weight. Exercise is more, weight is losing. So it's a negative relationship. And when your shoe size and exam score, right? If your shoe size is bigger, that's not guarantee that you will get a good exam score. So in that case, there is no correlation, right? One thing you have to understand as well is that correlation means there is a relationship between two features. But is that the cause? That is not compulsory. What does that mean? Let's try to understand. There is a very nice example which we have. People have found out a correlation between two interesting features. What they found out is, when you are eating more more chocolates, the chances of winning the Nobel Prize is higher. you can see that based on the countries where the consumption of the chocolates are higher, the Nobel Prize winners are more. You can see in Switzerland, there are more consumption of the chocolates. They have the highest Nobel Prize winner, right? But that is a correlation. But is that the cause? The answer is no. अगर ऐसा होगा तो मैं तो सब आइसक्रीम खाना चॉकलेट खाना चालू कर दूंगा, right? I will get the Nobel Prize. It's not the case, right? It's just a relationship which we found out. So correlation does not mean it's a cause for it, right? That's why there is a very famous sentence: correlation is not causation, right? Correlation is not the reason behind that. It can be a reason, but it is not sure, right? We have to understand that also. So for example, here, if you are getting more Nobel Prize, that means you are consuming more chocolate. That is the reason. The answer is no. Although you found the correlation, but that is the reason, that is the cause, the answer is no, right? So basically correlation is a good number, but will that be a cause? That may be possible, that may not be possible, right? Now, how do I measure the correlation? There are multiple ways we have, but these are the two major ways which people are using. One is known as covariance, and second is known as correlation coefficient, which is also known as Pearson correlation coefficient, right? It is also known as Pearson correlation coefficient, right? This correlation coefficient is also known as Pearson correlation coefficient. So these are the two measures which we have for calculating the correlation. Now, how we can do that? We'll try to understand this. But till this point, what we have discussed, are you guys clear with this, all of you? Any doubts on any of the pointer which I have mentioned? Okay. What if two variable decreases together? It's a positive correlation. But two variable decreases means what? One is decreasing, other is decreasing. How is that possible? If one is decreasing, that means decreasing means what? Like this, right? And one other is also decreasing. How the chart will look like? I'm just thinking. This is increasing. This is decreasing. But here one is increasing, other is decreasing, right? When both are decreasing means what? When both are decreasing means what? It's something like this only, right? Or maybe something like this. It's a positive only. Okay. Because at the end, the slope is, you have to understand the slope, right? Slope is like this. Here the slope was like this. So when one is decreasing, other is decreasing, मतलब ऐसा होगा. तो slope तो उसका ऐसा ही है ना. So it's a positive only. So when the slope is like this, 45-degree line, it's a positive correlation. If the slope is like opposite direction, in that case, it's a negative correlation. Okay. So covariance tells us two variables vary together, right? So basically the covariance is nothing but one of the measures which is helping me to understand how well you are correlated. Okay. Now here is the formula which we have to follow and we have to calculate the correlation. If two people laugh and cry at the same time, they have high positive covariance. If one laugh while other cries, they have negative covariance, right? But we'll try to understand this with one example, how the calculation happens. This is the formula for the covariance. 1 by n summation of I equal to 1 to n xi minus x bar into yi minus y bar, where xi and yi are the values, x bar and y bar are the mean, that is mean of x and y, and n is the total number of data points. Let's take this data set and let's calculate the covariance value, right? So let's try to understand this, how the calculation happens. So I'll be opening Excel. Let's quickly do that in Excel so that I don't have to use calculator. So 246, 246, 40, 60, 80. This is your study hours and marks. Study hours and marks. Okay. So this is my data point. And my interest is what? My interest is to find out the covariance. As of now, we are discussing covariance. There are certain problems with the covariance as well. All those things we'll discuss. But let's calculate that first. Formula says that xi minus x bar into yi minus y bar. Right? That means I need x bar and y bar. And x bar and y bar is nothing but your average. Average of x and average of y. So let's calculate the average. This is my average of x and this is my average of y. Okay. Now what is the formula? Xi minus x bar. So let me calculate my xi, which is nothing but study hours minus study hours average. And same way yi minus y bar, right? So yi is my marks minus marks average. Okay. So xi is what? Xi is nothing but this value minus x bar is what? X bar is nothing but this value. Let's go to the second one. Xi is what? Xi is this value minus yi is, sorry, xi is this and y bar is this, y average, right? X bar, sorry, xi minus x bar. I got these values. Same I will be doing here also. Yi minus y bar, yi minus y bar, yi minus y bar, right? So I got these numbers. Now, as per the formula, it is multiplication of xi minus x bar into yi minus y bar. That means this multiply by this multiply by this, and this multiply by this. So xi minus x bar into yi minus y bar. That is nothing but xi multiply by, sorry, xi minus x bar multiply by yi minus y bar, xi minus x bar multiply by yi minus y bar, and same way xi multiply by yi wala average, right? And now when I do the sum, why we are doing the sum? If you see the formula, I have to sum up this summation sign, right? Summation of I is equal to 1 to n. For all the rows, whatever calculation you did, sum it up. We did the sum. Now I want to divide that with 1 by n. N is nothing but total number of records. We have 3 records out here. So I will be dividing this 80 by 3. So my covariance is coming out to be 26.6667. So the covariance between x and y is how much? 26.667. Right? Are you guys understanding this, all of you? How to pass this? I'm not sure how to use this formula. Let me just check. Array 1, comma, array 2. See? 26.6667, right? Covariance of population, this, comma, this. Let me go with covariance of sample. What was sample? Divide by n minus 1, right? If I divide this 80 by n is 3, 3 minus 1 is 2, so 40. Let's see covariance of sample, this guy, comma, this guy. Perfect. 40 is coming in. Let me repeat this. I see some of the learners not getting it. So let me repeat this. See, this is my data point. 2, 4, 6, 40, 60, 80. Hours study, marks. 2, 4, 6, 40, 60, 80. Right? This is my data set. Now what I want is, I want to calculate the covariance. What was the formula for the covariance? The formula for the covariance was, covariance between x and y is 1 upon n, summation of I is equal to 1 to n, xi minus x bar into yi minus y bar. These are my xi's, these are my yi's, right? What all I want? N I already know. N is nothing but 3 records. So n is 3. X bar and y bar I want. And x bar and y bar is nothing but the average. So I want the average. That is average of your x, average of your y. So I got the averages. Now once I got the averages, now what? Xi minus x average. Xi is this, x average is this. Yi minus y average. Yi is this, y average is this. So let's do that. Xi minus x average, yi minus y average. Xi is this minus x average. Xi is this minus x average. Xi is this minus x average. Same way for yi also. Yi is this minus y average. Yi is this minus y average. Yi is this minus y average. So I got my xi minus x average. I got my yi minus y average. Now I want to multiply, right? So xi minus x average multiply by yi minus y average. That is nothing but xi minus x average multiply by yi minus y average. Same way xi minus x average multiply by yi minus y average. And same way xi minus x average multiply by yi minus y average. So we are done with this part. Now we have to sum it up. Summation. So I'll be summing it up. Sum of all these 3 records. That is coming out to be 80. Now I want to divide that with n. N is nothing but my total number of records. We have 3 number of records. So I'll be dividing that with divide by 3. So this is my covariance. This is my population covariance, right? If you see the population covariance formula, covariance dot p, I am passing my x, I am passing my y, and the variance which you are getting is 26.666. Same way covariance of sample. In sample, what we do? We divide it with n minus 1. N is here 3. 3 minus 1 is 2. So what is 80 by 2? 80 by 2 is nothing but 40. So we are getting 40. Let me use the covariance sample formula as well. This is my x. This is my y. You can see that my covariance for sample is coming out to be 40. Are you guys getting this, all of you? Okay. Now, there is one more concept called covariance matrix. Now, what does covariance matrix means? Difference between population sample, we already discussed that in the standard aviation class, right? Are you not there in that class? Please go through the recordings. Any doubts, you can let me know. Population is nothing but overall data. Sample is nothing but I'm taking sample. For example, let's say I want to predict, I want to find out whether BJP will win or Congress will win. So what is population? The entire India population. But will I go to every individual and ask whether BJP will win or Congress will win? I cannot do that, right? It's a cost for me. So what I do, I take a samples. And when we take a sample, then my formula changes. And why it changes, all those things we had a detailed discussion. Go through the recordings. Okay. All right. So now what I wanted to discuss is covariance matrix. Now, what is a covariance matrix? Let's try to understand covariance matrix, right? Covariance matrix is nothing but it's a when we are having two features, for example. So I will be having this type of matrix. X is there, Y is there, X is there, Y is there, right? Here I will be calculating covariance of X and X. Here I will be calculating covariance of X and Y. Here I will be calculating the covariance of Y and X. And here I am calculating the covariance of Y and Y, right? Let's come to the formula. What is the formula for covariance of X and Y? The formula for covariance of X and Y is 1 upon n summation of I is equal to 1 to n xi minus x bar into yi minus y bar. Can I say that covariance of X and Y is exactly same as covariance of Y and X, all of you? एक ही बात है ना? X को आगे कर लो पीछे कर लो बात तो एक ही. It's one and the same thing. So my covariance of X and Y is exactly same as covariance of Y and X. You can see here. It's a symmetric. Covariance of X and Y is equal to covariance of Y and X. Okay. That means we already calculated that. 26.61 something, 26.61 something, which we calculated in the Excel. 26.66, right? So that is what these two numbers are. Let me go to this guy. Covariance of X comma X. 1 upon n summation of I is equal to 1 to n xi minus x bar into xi minus x bar. What is this formula? You already know this formula. Can you tell me what is this formula? Covariance of X comma X 1 upon n summation of I is equal to 1 to n xi minus x bar whole square. What is this formula? Perfect. It's a variance, right? All of you remember the variance formula. So it's a variance. So can I say that this part is nothing but the variance of X and this part is nothing but the variance of Y, right? And that is what you can see here. Variance of X, variance of Y. So if I want to create the correlation matrix for this particular data set, so we already got the two numbers. We already got this diagonal numbers 26.66, 26.66. I need to find these two numbers, right? This is my X, X, Y, Y. This is my variance of X. This is my variance of Y. Let's calculate that. What is the formula? 1 by n into this into this. इसी को multiply करना है. So I need xi minus x average square, right? So basically this value raised to power 2. This value raised to power 2 and this value raised to power 2. I'll sum it up and this I will be dividing by 3. 2.666, 2.666. Same way I will be doing for y as well. yi minus y average whole square. So what is my yi minus y average raised to power 2? Yi minus y average raised to power 2 and yi minus y average raised to power 2. Let's sum it up and divide that by 3. 266.677. 266.67. So what is my final matrix? My final matrix, covariance matrix is what? My covariance matrix is something like this. 2.666, 26.66, 26.66, 26.666, right? This is my covariance matrix. Are you guys clear with this covariance matrix, all of you? As of now, I am having only 2 features. If I am having 10 features, it will be 10 cross 10 matrix, right? Okay. As of now, we have only x and y. Suppose I have x1, x2, x3, x4. So automatically my matrix size will increase. Okay. So that is the idea. So we have, when you have multiple variables, you calculate covariance between each pair and store them in the square matrix. That is known as covariance matrix. It's symmetric. Covariance of x, y is equal to covariance of y, x. But the problem with covariance is what? But this is whole square. Whole square as in? Am I missing something? xi minus x average whole square ही कर रहा हूँ ना मैं तो. Minus 20 whole square. This whole square. This, then I am summing it up also. Then dividing it by n. If I calculate the variance population for this column, what I am getting? 260. सही तो है. If I am calculating the variance of x, right? That is fine. All right. So now let's get into the problems. Now, what is the problem here? If you see this 26, right? Suppose I am coming up with one, this thing, right? One number. You tell me whether it's making sense or not. Suppose I am saying the covariance between experience of Accenture employee and salary is 15. Covariance of Deloitte employees experience and salary is, let's say, 10. So if I ask you which particular company has a highest covariance or which company has a good correlation, which company is coming in? Accenture, because the covariance is higher. So when you are having 2 different data, then it is making sense that 15 is higher. That means company Accenture has a good correlation between the experience and salary. But suppose I am having only one company's data, Accenture. Now by seeing this number, can I say that the covariance is higher? Because the covariance value is varying from minus infinity to plus infinity. Minus infinity to plus infinity. So 15 is high or low? Will I able to tell that properly? No, right? I cannot tell it properly. Yes, 15 is good number, but it can go up till infinity also. Then this 15 is what? It's just a number for me. It's not making sense to me, right? That is why it is saying that it is not standardized. The first point, it's not standardized. Suppose I have some restriction that my covariance value vary from only this to this. More towards this, better the covariance is. More towards this, worse the covariance is. Something like that. If I have a smaller range, कि मेरा कोवेरियंस वैल्यू लेट से -1 से +1 घूमता है, अगर +1 होगा तो वो पॉजिटिव कोरिलेशन कोवेरियंस माना जाएगा, और अगर -1 होगा तो नेगेटिव कोवेरियंस माना जाएगा. बट यहां पे देयर इज नो रेंज, द वैल्यूज आर फ्रॉम -infinity to +infinity. So if I say that my covariance is 15, will I say it high or low? I cannot answer that, right? Because it can vary up to infinity. So that is not making sense, right? So that is one of the problems which we have. Now, what is the second problem? The second problem is, if you go back and check, the second problem which you can see is, you can't easily say, which I already discussed, right? 20 matlab kya hai, -15 matlab kya hai, because of the range, infinity and +infinity, -infinity. Second is units. Suppose, let's say you are finding the covariance of years of experience and salary in rupees, right? Suppose you are finding the covariance of experience in years and salary in rupees. You will get certain covariance number. But when you change the unit, suppose now you changed your data from experience in months and salaries in dollars. For the same data set, data exactly same है. जो यहां पर तुम्हारा डेटा था वही डेटा यहां पर भी है. It just तुम्हारा यूनिट चेंज हो गया है, राइट? योर यूनिट गॉट चेंज्ड. तुम्हारा कोवेरियंस वैल्यू भी चेंज हो जाएगा. एक छोटा सा एग्जांपल करके देखते हैं, राइट? Let's say I have an experience and I have a salary. We'll use the Excel formula only and we'll check it out. So let's say I have the 10 years of experience. Salary is, let's say, 1,50,000. 5 years of experience. Let's say the salary is 1 lakh. 2 years of experience. Let's say the salary is 50,000. And 1 year of experience. Let's say the salary is 30,000. 8 years of or 7 years of experience. Let's say salary is 75,000. This is my data set, right? Now let me calculate the covariance. Covariance of this particular data set. My covariance is coming out to be a big number, right? 1,26,000 because of these bigger numbers. Now let me go ahead and convert this particular data. This is as of now into years and this is as of now into rupees. Now I will be having the experience again, but this time it is in the months and this is gonna be in the dollars. Let's assume that the dollar rate is 82 rupees. So 10 multiplied by 12. Right? These are the numbers I got. Same way dollar, this divided by 82. Now let me calculate the covariance. See this? My data is exactly the same. It just my unit got changed. Here my covariance was coming out to be 1,26,000. Here my covariance is coming out to be 18,000. So that is the third problem, right? When the unit changes, your covariance number also changes. So these are some of the problems which we have. And to take care of this problem, another measure is coming into picture, which is known as Pearson Correlation Coefficient. What is the benefit for that? The benefit for that is, first of all, it ranges from -1 to +1. Right? It ranges from, let me pass it in the quotes, I guess. Yeah. So it ranges from -1 to +1. Unlike your covariance is ranging from -infinity to +infinity. Right? That is the first benefit which we are getting. Now, what is the benefit here? Suppose I say that, okay, in Accenture, the correlation between salary and experience is 0.8. So I know that it's very high. Suppose in Deloitte, the correlation between salary and experience is 0.95. I know it is high. Suppose I am saying that the correlation between the scholar, salary and experience is 0.2. I know it's low, right? So I am understanding the value. There the value is making a lot of logical sense. Suppose the correlation between your, what do you say, uh, any negative value, for example, house price and the distance from the city. So when when the distance is increasing, house price is decreasing. It's a negative relation. So my covariance value will be more towards negative value. Let's say -8, -0.8, right? So I can say that it's a strongly negative correlation value. So when I am having the number in one range from -1 to +1, if you are more towards -1 or if you are more towards +1, I am getting a confidence that the correlation is good. If you are more towards 0, I am getting a confidence that the correlation is not there. So that is the benefit which I am getting, that it ranges from a smaller range of number, -1 to +1. Second benefit is that when unit changes, my correlation value does not change, right? When the unit changes, my correlation value does not change. And that is very interesting and very important as well, right? So that is the benefit which we are getting using the Pearson correlation coefficient. Now we'll go ahead and we'll try to find out, right, how it actually works. So this is the formula for the correlation coefficient. Correlation is the standardized version of covariance ranging from -1 to +1. Pearson's correlation coefficient, the formula is covariance of x and y upon standard deviation of x multiplied by standard deviation of y, right? That is the formula which I have for the Pearson correlation coefficient. Here you can see the meaning of it. If the correlation value is more towards +1, it's a perfect positive correlation. If it is between 0.8 to 1, strong positive correlation. 0.5 to 0.8, moderate positive correlation. 0.3 to 0.5, weak positive correlation. 0, no correlation. -0.3 to 0.5 negative, weak negative correlation. -0.5 to 0.8 negative, moderate negative correlation, and 0.8 to -1 is a strong negative correlation, right? So that is giving me the understanding about what type of correlation you have. Is it strong, weak, moderate, and so on, right? But now, before I proceed further and take one example to calculate all these things, I also want to help you understand about bit of the covariance again, right? This is you should be aware of. Let's try to understand this, right? Suppose this is my data point. And this is my average, right? This is my X average. This is my y average. In this particular data, will my covariance positive or negative? What do you think? In this particular data, will my covariance positive or negative? What do you think? Positive, right? But now I will prove you that why it is positive, right? Suppose this is my point. Let's say P1. This is my point. Let's say P2. Let's say this point is nothing but x1, y1. And this point is nothing but, let's say, x2 and y2. What was the formula for the covariance? The formula for the covariance was 1 upon n, summation of I is equal to 1 to n, xi minus x average into yi minus y average. Let's take the first point, this point. What is xi minus x average? Positive or negative? Xi is small, x average is bigger. So xi minus x average is what? It's negative, right? Why positive? xi छोटा है, x बार बड़ा है. तुम छोटे से बड़े को माइनस कर रहे हो. Let's say 5 minus 10. Will I get positive or negative? Negative. So can I say that for the first point P1, my xi minus x average is a negative number? Same way, what about my yi minus y average? Positive or negative? yi छोटा है, y average बड़ा है. छोटा माइनस बड़ा क्या होगा? नेगेटिव होगा. So negative into negative. What is negative into negative? Positive. Let's go to second point, P2. xi minus x average. Positive or negative? x2 is बड़ा, x bar is छोटा. बड़ा minus छोटा is positive. So positive. What about y2 minus y bar? y2 बड़ा, y bar छोटा. बड़ा minus छोटा is positive. What is positive into positive? That is also positive. So can I say that when all the points which are falling here, all will give me positive, 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 positive. Final outcome will also be positive. If I take the average also, then also it will be positive. So for this particular data set, my covariance will be positive. Let's take second scenario. My data is something like this. This is my mean. This is my one point. This is my second point. This is, let's say, x2. Let's call it as y2. Let's call it as x1. Let's call it as y1. Right? Do the same story. 1 upon n, summation of I is equal to 1 to n, xi minus x bar, yi minus y bar. What is xi minus x bar for this point? xi is chota and my x bar is bada. So xi minus x bar is what? Negative. So negative. yi is bada, y bar is chota. yi minus y bar is what? Positive. Positive. What is negative into positive? Negative. Same way for the second point as well, this point. x2 is bigger, x bar is smaller. So what is bigger minus smaller? Positive. Same way y2 is smaller, y bar is bigger. y2 minus y bar is what? Negative. What is negative into positive? Negative. So can I say that for every point, my values will be negative, 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 negative? Divide by n, it is also be negative. So when your data is like this, what covariance value are you getting? A negative value. And when your data is like this, what covariance value you are getting? Positive. Is that making sense, all of you? Why the covariances are negatives and positive in this type of data set? Okay. All right. Now let's get into this calculation, right? This is the formula we know, standard deviation into this. We'll try to take one example to calculate the covariance. Let's say this is my data set. Study hours, marks. 24653, 50, 60, 75, 68, 58. Okay, 58. See, we can create a chart directly and we can understand that, right? Whether it's positive or chart देख के मुझे पता चल जाएगा positive है negative है. ये chart देख लेते हैं यहाँ पे. Positive ही होगा, right? You can see that it's going upwards. So my correlation will be a positive correlation. That is, I am very much sure by seeing the chart. But what is the exact value is what we need to find out. Okay. So let's do that. What is the formula? The formula is covariance of x comma y upon standard deviation of x multiplied by standard deviation of y. So I want to calculate. एक्सेल से हम लोग बाद में करते हैं, पहले खुद ही कर लेते हैं एक बार, है ना? तो लेट्स कैलकुलेट द एवरेज ऑफ this guy and average of this guy. ठीक है, I got this. I also want the standard deviation as well in my calculation. So standard deviation, I will be using all population for now. Standard deviation and standard deviation. Okay, I got the standard deviation as well. What else I want? Xi I know, X bar now I know, standard deviation I know. I think everything is with me. Let's start doing the calculation. So what I will be doing is I will be calculating what? First of all, covariance. Xi minus X average into Y, और पहले अलग कर लेते हैं, Yi minus Y average. And then I want to multiply Xi minus X average into Yi minus Y average. So Xi minus X average is what? This minus this. This minus this. This minus this. This minus this. And this minus this. Okay. Now same way here also. This minus this. 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 Now I'll do the multiplication. This multiply by this all over the place. And then I'll sum it up. I got 60. So here I got what? I got my numerator. Right? If you go back to your formula, I got my covariance of x and y. Now I want to divide this covariance of x and y. Again, मैंने इसको divide by n नहीं किया, n भी करना पड़ेगा. 1, 2, 3, 4, 5 records are there. So my covariance of x and y is divided by 5. That is 12. Okay. So I got my covariance of x and y as 12. Now I want to divide that with sigma of x and sigma of y, standard deviation of x and standard deviation of y का multiplication. We already calculated the standard deviation of x and y, right? So let's do the multiplication of this. This multiply by this 12.14. Now I have to divide what? I have to divide this guy by this guy 0.988. The covariance, the correlation value is coming out to be 0.988, right? Do we have any formula for correlation? Correl. This, comma, this. You can see 0.988. Perfect. Let me expand this. See this? Exactly same number coming in. 0.98799, 0.98799. Are you guys understanding this entire calculation, all of you? And as we are dividing with the standard deviations, right? It is never gonna cross more than 1. इसको normalize, standardize करने के लिए हमने standard deviation से divide किया. So when we are dividing that with the standard deviation, it will never gonna cross your value more than +1 or less than -1. And this is an important measure, right? This is an important measure. If I go back to Python, let's open Python instance. Let me take this data set, whatever data we got here. Okay, this is my data. See this 0.987997. 0.987997. Exactly the same number you are getting here. Correlation function. Right? So the correlation between the marks and the study hours is 0.997. Correlation between the study hours and study hours is 1 only. And that makes sense, right? Because you are comparing yourself with yourself. Let's calculate that. Let's calculate that. What you are trying to do? You are trying to find out the correlation between the study hours and study hours. How the formula will change? Xi minus X average into Xi minus X average. Covariance of X and X upon standard deviation of X into standard deviation of X. Right? Formula क्या हो जाएगा? If you go back to this formula, covariance of X and Y is this. What is the covariance of X and X? Covariance of X and X upon standard deviation of X, standard deviation of X. Right? So let's go and check it out. Covariance निकालते हैं पहले. Covariance क्या है? Variance ही होता है ना? अगर सेम ही फीचर को तुम करोगे तो वेरिएंस ही होता है. So let me insert one more column here and let me take the square. That is this square all over the place. Sum it up. I got 10. 10 divided by 1, 2, 3, 4, 5. 5 records. That is 2. And now I will be dividing 2 with 1.14 into 1.14. 2 का square root क्या होता है? 1.14. So this number multiply by this number only. I am getting 2. What is 2 by 2? What is 2 by 2? 2 by 2 is nothing but 1. So what is the correlation between X and X? 1. And that is what we are seeing here as well. Are you guys understanding this, all of you? If I will ask you what is the correlation of your height with your height, it's 100%, right? Your height is, let's say, 5 foot 5 inch, and your height is also 5 foot 5 inch. So what is the correlation? 100%. Try to understand visually as well. Try to understand visually as well. I have my height and I have my height. This is my data set. Let's say my first learner's height is 170 centimeter. Second learner's height is 175 centimeter. Third learner's height is 180 centimeter, 185 centimeter, 190 centimeter, 192 centimeter. Let's say these are the learners. Let's say this is my first learner, right? 170 centimeter, 170 centimeter. The point is here. Second learner, 175 centimeter, 175 centimeter. The point is here. Third learner, 180 centimeter, 180 centimeter. The point is here. Fourth learner, 185 centimeter, 185 centimeter. The point is here. Fifth learner, 190 centimeter, 190 centimeter. The point is here. Sixth learner, 192 centimeter, 192 centimeter. The point is here. Can I say that I am getting a straight line? And when I am getting a straight line, what is the correlation? It's a 45-degree line, right? It's a 45-degree line. And when you are having a 45-degree line, a straight line, the correlation is nothing but 1. Positive 1, obviously, right? Is that making sense, all of you? Why the correlation of the same column is coming out to be 1? I have shown you mathematically as well and visually as well. Give me a second. Okay. Now what I will be showing you is that I will be showing a plot. Right? Let me show you one plot here. This type of plot. This plot. This is a correlation heat map, right? Let me take one data. If you remember, we took one data yesterday. I think it was a tips data or something. No, it was another data. Let me take tips data, another data set. Okay. So let me take one data, which is your this data file, tips data CSV, which is present in your this thing, desktop. So let me go and get my Python. Yeah. So import OS. Ignore what we are doing in Python. We will have a detailed discussion in the future. Right? So don't worry about that. Okay. So here I have total bill, tip, and maybe size. Three numerical columns are there. So let me take these three numerical columns. And let me apply CORR. You can see correlation coming in. Correlation between size and total bill is 0.59. Correlation between tip and total bill is 0.67. Correlation between tip and size is 0.48. Now I will be creating one plot. You can see that you are getting this heat map, right? So basically relationship between the size and total bill is 0.6 correlation. Size and tip is 0.49. Tip and total bill is 0.68. You can see the same thing using the scatter plot as well. Here you can see. When my total bill is increasing, my tip is also increasing with some outliers, but you see a positive relation, right? And as you see a positive relation, you can see total bill and tip is coming out to be 0.68, right? Same way, what else? Total bill and size. So you can see here also it's like going up only, although it's not very much in linear, but it's positive only. So total bill and size is also positive, 0.6. Tip and size is what? Tip and tip is here, size is here, this one. This is also linear, but not that very much linear, but it's still 0.48, right? 0.48. So this plot is basically helping me understand about the numerical features, how the relationship between the numerical features are. We discussed in the last class as well, univariate, bivariate, multivariate. It's a multivariate analysis where we are taking three features: total bill, tip, and size. Right. Are you guys clear with the correlation, covariance, and everything what we have discussed today? Okay. So now what I want is I want you to try one calculation from your side. Then we'll check whether it is making sense or not. Okay. That is the last thing which we'll cover. Okay. Try to find the correlation between this. Give me the number. What correlation we have? Sleep hours and stress level. So calculate this. Do one thing. Let's calculate both covariance and correlation. Because obviously for correlation covariance you have to calculate. So do both, right? For correlation you need the covariance as well. So you'll automatically get both the numbers. So give me both numbers. Covariance and correlation. calculate manually, right? Don't use Excel and all. This is just for your practice purpose. -10 is what? Covariance or correlation? Correlation cannot be more than -1. -10 कहाँ से आ गया? Covariance is -10. Okay. Correlation is 1. Okay. So let's quickly check it out. Four, 6, 8, 7, 5. 80, 70, 60, 65, 75. 80, 70, 60, 65, 75. Yeah. I'm using Excel. You guys did the calculation, but I don't. Correlation -1. Perfect. Covariance 10. Perfect. Right. So the outcome is looking fine. And I will come back to the same example again before I end the session. Here you can see that I told you, right? Here you can see a relationship, and when the chocolate consumption is more, Nobel Prize is higher. What is the correlation value? You can see the correlation value 0.791. We denote the covariance value with R, small r, and here my covariance value is coming out to be 0.791, which is a strong correlation, right? So yes, correlation can be there, but is that a causation? The answer may be no, right? If that is the causation, I can start eating chocolates. Tomorrow I'll get the Nobel Prize. But it's not like that. Okay. So that is the main thing which you have to understand, that yes, when you're analyzing the data, you may see some patterns, but there can be a chance that that pattern may not make sense, right? That is very much a reality. So with that note, I'll end the session here. Any doubts you have, let me know. Else, I think we are good. We'll connect again tomorrow and we'll proceed further. But I hope you are understanding the entire mathematics in detail, which we are discussing, because all things are important. Python and all which we are discussing, ignore that, because we will start Python as well. And that time we'll understand all these concepts. Okay, how to create the code, how to write the code. All right, so have a nice day. We'll see you in the next session tomorrow. Till then, take care, guys.